Hi everyone, thanks for tuning in. Starting the presentation with this slightly long-winded title. If all you have is pathfinding algorithms, everything looks like a graph. Or how engineers focus on logic leads to worse software, which is a lot to get your head around. I'll get to the explanation of the title soon. But given that we've all been in lockdown and I've had far too long to think about this, there's a second title, which is creating a better schema for software engineers. Now, my name is Steve Hopkinson. I'm a full stack JavaScript engineering lead. I'm currently working as the front-end lead of an engineering team delivering a thick client fintech application for JP Morgan Chase. Prior to that, I was back-end lead of a team delivering Node microservices for Lloyd's Banking Group. But coding is actually my second career. My first career was as an arts and science journalist and writer. So if at any point in this talk you think that things are getting a little bit soft, a little bit philosophical, there's your explanation. It's because I spent years on the arty side of the divide before coming over to tech. So why am I giving this talk? What is my motivation? Through my career, I've worked with a wide range of engineers in a lot of contexts, both on the front end and the back end, as a peer of theirs, as a manager, and also in my first career as a client, I suppose. Somebody who was not on the engineering side, but who worked with engineers to develop a product. And across these experiences, I noticed a pattern of a lot of engineers who focused their efforts quite narrowly on writing logic, the sort of nitty-gritty of the code, sometimes at the expense of other important skills for delivering what we needed to deliver. Now, in contrast, I tended to find that high-performing engineers generally took a much more holistic view of their work, seeing their role as being about a lot more than just writing if statements and for loops. And so I wanted to explore some of the causes of this kind of divide and search for some solutions. So in my second title, I mentioned creating a better schema for software engineers, which begs the question, what is a schema? Now, it's a familiar term for many engineers, but it's also a key term within psychology. Now, a psychological schema is essentially an individual's mental model or a pattern of thinking that allows them to organize categories and the relationships between them. It's a framework for making sense of the world around them, shaped by their experiences. Now, schemas are how we make sense of the world, and we use them as shortcuts for thinking about things. The world is extremely complex. If we were constantly dealing with it in its kind of raw form, it would be quite overwhelming. And so instead we have heuristics. We ask ourselves simplified questions, and often that means relating things back to our schemas, which means that we're more likely to accept information that reinforces our schemas and to reject information that contradicts. We have schemas for how we think about everything, from kind of human elements like friendships and parenting, even through to how we think about ourselves. And these are called self-schemas, the kind of mental model for how we think about ourselves in life. And these are extremely important. So if a self-schema becomes self-defeating, if we have a model of ourselves that has a mainly negative impact on our lives, we can say that that schema is maladaptive. It's kind of an adaptation that has had a negative impact on our ability to deal with the world. So that might be things like perfectionism or a sense of inferiority, any of those things. Now, kind of extending that, the way I think about it is that individuals will play many roles throughout our lives. Our self isn't just in a single role constantly. We move through many roles. And for each of those roles, we will have an internal model of what we should be doing in that role, whether it's a kind of romantic role, a family role, or a professional role. And so we have a series of role schemas, if you will, which are our mental models for those roles that we inhabit. Now, why does this matter to a software engineer? So maybe a bold statement, but from my experience, I would say that many software engineers have what you might call a maladaptive role schema, a mental model of their own roles professionally that have a negative impact on their working lives. So how does this happen? I thought to explore that, we might look at something I've seen in an area very different from software engineering, which is football. Here is a clip of the famous player Maradona, who died last year. And this is kind of a highlight reel of some of his top moments. And there are hundreds of videos like this on YouTube, kind of highlighting the most individually talented players, their abilities, and kind of really demonstrating the peak of their technique and skill. So these highlight reels, as I say, they're compilations of individual footballers' greatest moments, commonly profiling the most technically gifted players. So your Maradonas, your Ronaldinhos, your Messis. They almost exclusively tend to focus on what players are doing when they have the ball. And there's often a focus on dribbling, which is, as many of you will know, kind of an individual skill that demonstrates technique, ball control, speed, physical strength, and intelligence. And because of sort of issues with broadcasting rights, these highlight reels are often a more accessible way of watching football than actually being able to watch actual football matches. Now, from watching these highlight reels that, have this very individual kind of technique focused view of footballers, you could develop a role schema of what a footballer should be doing, which is that a footballer is someone who uses their individual skill to outwit opposing players through their personal technique and strength. And, on the basis of things like that Maradona highlight reel, that certainly seems accurate. But to see the other side of things, it often goes wrong. So here is Cristiano Ronaldo, not meaning to pick out anyone in particular, but this is the other side of dribbling and the application of individual skill. It goes wrong quite a lot. And when it goes wrong, it tends to have a very high cost for the team. It looks pretty stupid, and it's not really helping anyone in terms of what you're actually trying to achieve in football. So this, to me, highlights that this highlight reel role schema is maladaptive. It's a model of how to play football that is actually having a negative impact on how many people approach it. Because football itself is not an individual sport, of course. Success isn't measured by what you do as an individual, but by collectively achieving goals. So high skill individual plays like dribbling, they're inherently high risk, and failure often has a high cost to the team. There are usually safer options available as a footballer that are more likely to result in a good team result. Passing to another teammate who's available, or going for goal, or just moving the space around in a way that, opens up the opponents rather than trying to, take all the responsibility on yourself. These clips also overlook more important skills, such as movement off the ball, how you're moving when we don't have possession. And so in the place of what you might call the highlight reel role schema of a footballer, we need to create a healthier self-image of what's required to create a more kind of heuristic model of what a footballer should be doing in order to achieve the best result. And that role schema might look something like this. A footballer is someone who uses their abilities to maximize their team's chance of achieving the best result. And, this isn't just something that's limited to football. If you're a musician, you can imagine that guitarists who grew up listening to Van Halen might come out of it imagining that the role of a guitarist is to play a lot of notes as quickly as possible, which ultimately leads to some pretty terrible musicians. A more heuristic view of what being a musician would mean would avoid some of those, missteps in terms of how we conceive of our own roles. Now, how is this relevant to software engineering? So software engineering, in my experience, is preoccupied with logic. Learning to be a software engineer is often synonymous with learning programming languages. And that learning often focuses on logical constructs. So if-else statements, loops, switches, all of these different things that we have available to us. And equally, online resources for improving development skills, such as Leetcode and Code Wars, often focus on improving individual logic writing skills, but rarely explore other domains such as data modeling or requirement gathering. Interviews for engineering roles, especially for quote-unquote aspirational roles like FANG, so Facebook, Google, etc., often focus on solving complex algorithmic problems, so things like pathfinding algorithms. And also many software engineers are entering the field through studying computer science, which has a strong focus on algorithm design and optimization. But of course, computer science is not software engineering. They're overlapping but quite distinct fields. Even the language that we use to talk about software engineers reinforces this bias. You know, we talk about ourselves as coders, we talk about ourselves as programmers, even though often the majority of our role doesn't involve writing code or programming. It's a much more wide-ranging skill set. And my view is that this focus on logic, much in the way that watching highlight reels of footballers create a very limited view of what a footballer should be, this focus on logic within software engineering creates quite a limited view of our roles as software engineers, which is that engineers are people who use their individual skill to solve problems by writing logic. But now here's a screenshot from a project I worked on a long time ago. And what I'm trying to show here is that this focus on logic often overlooks the fact that logic can be software's worst enemy. And an excess of logic in particular can make software very, very difficult to work with, both as a user and as a programmer. So this was a code base that I picked up from another team. And you'll see the second line here says that the one particular function has an n path complexity. That's the number of paths through the function of 20 trillion, which is quite a few. The limit that we'd configured for complexity was 200. So we've overshot the mark quite a bit there. And this was really a project where, you know, just mindlessly adding logic on top of logic really caused us a lot of issues. So kind of what is the issue with this kind of logic first role schema? Well, first of all, engineers who focus on logic as the main responsibility of their role are much less likely to pay attention to non-logic tasks. You know, as we discussed earlier, we use these schemas to kind of shortcut how we process things. And so if we focus on logic first, we're much more likely not to pay attention to kind of non-logic tasks and responsibilities, such as styling, data modeling, documentation, and shaping requirements. Engineers are more likely to prioritize logic-focused tasks, or to try to resolve issues upstream of implementation by adding additional logic. So, for example, finding out at the implementation stage that the data model was wrong, and so bunging in a load of code to kind of fix that at runtime. And this additional logic that we add to fix upstream problems at implementation creates what we might call accidental complexity, which is logical complexity that isn't fundamental to the problem we're trying to solve. It's incidental and it's introduced at the implementation stage. I've also seen that engineers who see their role as being to write logic are much more likely to choose to solve problems by implementing solutions from scratch, even if problems have already been solved elsewhere, which can lead to not invented here syndrome, as it's occasionally known. And I think the reason for that is, you know, often problems like pathfinding or things like calculating the difference between two strings, these are solved problems, but they're also quite enjoyable tasks to solve from a logical perspective. And so if we see our job as being to write logic rather than to build software, we will often tend to prioritize fixing the problem ourselves rather than looking to see if the problem has already been fixed. Now, why is this excessive logic bad? In my experience, very few requirements are fundamentally logic problems. You know, there are very few requirements that come in that are fundamentally pathfinding issues or, you know, about calculating Levenstein distances or other kind of classic examples of algorithmic issues. Particularly in the front end, those issues are quite unusual to come across. which means that most of the logic we put in our applications is incidental to the task at hand. It's not kind of fundamental to the problem we're solving. And even our kind of front door process, as we're bringing in requirements, complex logic in requirements. So, a requirement where a single feature might have a lot of different branching paths that have very different outcomes depending on where the, flags or thresholds go one way or another. Radical changes above or below those thresholds, etc., are often a sign that the requirements themselves need to be refined, because these kind of very complex outcomes are very hard for the user to make sense of often. The more logic that exists in an application, the more that has to be communicated to the user, or even worse, hidden from the user, and this often results in a worse user experience. And on top of that, logic, probably more than any other element of our jobs, is very difficult to reason with, expensive to create and maintain, and a source of bugs, errors, and edge cases. I think it's often said that it's twice as hard to read a piece of code as it is to write it. And so if we're writing complex logic that's the limit of our ability to reason, then it'll be almost impossible for people to actually make sense of that reading it back. Fixing these issues that are created often results in piling additional logic on top of the logic that already exists, which only exacerbates these issues. As a rule of thumb, I would say, as an engineer, a well-designed application should contain the least amount of logic necessary to deliver the required functionality. And obviously, if we do have a lot of engineers who believe their role is just to write logic, then these rules of thumb are kind of pulling in opposite directions, which kind of creates tension within teams. So what can we do about this? I'd kind of divide this into two areas. What can we do as organizations and team leads versus what can we do as individuals ourselves? Now, as organizations and team leads, I think the most important thing is always to create culture. And certainly I've worked in teams before that place kind of complex logic on a podium. Team leads would really praise the engineers that write, these extremely complex, multi-layered algorithmic solutions. Whereas the engineers who are kind of diligently pushing back on introducing that complexity at the requirements gathering stage are often much more underappreciated. So organizationally and as team leads, we can work to create a culture that doesn't place complex logic on a podium, but instead praises decisions and engineers who choose to simplify and improve the application throughout the process. Also, in terms of team building, obviously recruitment is a huge part of that. So we can try to ensure that application and interviewing processes do not unduly focus on solving logical problems. So that's essentially, grilling candidates, getting them to write breadth first search algorithms or A-star pathfinding algorithms, interview, often for roles where those abilities will never be used. So trying to consciously avoid placing a focus on solving these logical problems, particularly when recruiting for roles where the majority of the work will not be kind of intense algorithmic work, particularly in the front-end field, in my experience. And equally, encouraging processes and behaviors that push back on the introduction of unnecessary logical complexity. And that's in two stages, really, both as we're refining requirements, ensuring that we are pushing back on requirements that seem unduly complex in how they formulate an issue, and also at the peer review stage, encouraging code reviews among peers that, highlight complex logic that's difficult to reason with, and encourage developers to kind of go back and find simpler ways to deal with these issues, potentially by moving some of that into a different domain, by simplifying the data model, or just by expressing that logic in a way that's simpler to understand, maybe with more declarative code, or in a way that makes things easier to reason with. There are actually some linting tools out there that can automatically check for complex logic. TS-lint has a cyclomatic complexity rule, which allows you to essentially set a limit above which you will not pass a linting test for code complexity, but that's a fairly blunt tool, and I don't think it gets to the root cause of the issue. As individuals, we can invest more time in strengthening areas of our skill sets that are often overlooked, really drilling down into data modeling, looking into core concepts like data normalization, looking a bit more into how we handle styling. I see a lot of, particularly with the rise of kind of CSS in JavaScript, I see a lot of complex logic employed to kind of generate styles at runtime, which can be very difficult to reason with as engineers. So again, finding a more declarative approach to how we declare our styling, and also investing time in understanding how we refine requirements. I think too often as engineers, we put less effort into refining the requirements that are coming in because we're confident that we can fix whatever happens at implementation. But again, that only results in more accidental complexity. But also as engineers, we can seek to consciously embrace a more holistic self-image of our roles as engineers and to continually evaluate our own decision-making against that schema. So we're constantly evaluating our own behaviors against an idea of our role that is more kind of all-encompassing in terms of the results that we're looking to achieve. And as I wrap things up, I'll leave us with an idea of what a healthy role schema for a software engineer might look like. And in my mind, that's something along these lines. A software engineer is someone who uses their abilities to create software that fulfills the needs of its users and is easy to scale and maintain. And often that is something that we can achieve while writing the minimal amount of logic, which for many of us who've learned software engineering through doing algorithmic challenges or from computer science, that can seem quite contradictory to how we think about our roles. But as touched on before, this excessive logic is quite contradictory to these, I think, hopefully quite global standards of what writing good software looks like. So thank you for listening. I appreciate that might have been a little bit more abstract than some of the talks that are often given at JS Monthly, so I appreciate your patience and understanding in listening to this. I'm very sorry I can't be there to answer your questions, but please do reach out to me on Twitter. I can be contacted at Steve_Hopkinson or by email, steve@stevehopkinson.co.uk. I'd always love to hear from your insights, both in terms of your individual experiences, or maybe if you've encountered this at an organizational level, or even if this is something that you've just encountered as an individual, and maybe any steps that you've taken to try and resolve similar issues. So thanks again for listening. I hope you've had a great evening, and I hope to see you in person at a JS Monthly event soon. Thank you very much.